Alright, this is page 47. You already did the back of this paper. We're just going to look at the front. The front is kind of rounding everything together. We had three transformations. We had translation, reflection, rotation, which is a slide, a flip, or a spin. You should have noticed that after every practice problem we did, the resulting figure had the same size, the same area, the same angles, and the same line lengths. The same size, area, angles, and line lengths. That's because the resulting figure was like a carbon copy of the first one, right? That's called isometric or isometry. Isometry is just a vocab word to let you know that there's a transformation that preserves. Preserves means maintains, keeps, holds steady, distances and angles. So the shape stays the same appearance, the same size, everything. Another way to call this is a rigid transformation. Rigid transformations are another way to describe the types of things we've been doing. Which brings us to the discussion congruent versus similar. I want you to box that in. This is also a preview of what's to come. So everything that we did resulted in the exact same shape and size, right? It was just in a different spot. Okay, so that means that it's congruent. If one shape matches another by using just a slide, flip, or turn, then they're called congruent shapes. If two shapes if one of them has to be resized, made bigger or smaller to match the other one, that's called similar. And this is actually a preview of where we're going starting next week. The good news is everything we did this week, which is on the test, and last week, results in congruent shapes. Okay? I did it that way so that if you ever graphed it and the shape didn't match, you knew something was wrong because all of ours should be congruent. Okay? Then rotations, we learned that 2 days ago, and then we practiced it yesterday. Rotations means you're just rotating around the center. We are always rotating around the origin. That means that the distance from the center to any point on the shape would stay the same every time. If you were to, say, hold your finger down on the center and then hold your pencil down on a corner, and as you rotate it, it will draw a circle. So every point makes a circle around the center. Something that is neat about rotations, rotations can be achieved by performing two composite reflections. What that means is instead of taking a shape, instead of taking a shape and rotating it 180 degrees, right? You could reflect down and then reflect over, and notice it's still upside down. Do you see that? So what it's saying is some rotations, like the 180 one, can also be achieved if you simply reflected down and then reflected over, and you have the exact same resulting figure. Rotations of 180 degrees are equivalent to reflecting through the origin. I did put on here a nice, beautiful little chart with your rotation rules, and you will notice this chart covers both clockwise and counterclockwise, which is nice because you can see that the clockwise rule is the same as the counterclockwise rule, depending on degree. Remember, in the rules, the only part that really matters is what comes after the parentheses, right? The part in the front is just saying, hey, take your X and Y's and do this. So what comes after that arrow is where you actually see the rule. Now during the test tomorrow, I'm going to give you the rules. You have to know how to apply them. Okay? You with me?
Yeah.
All right. Go to the back of this. You were supposed to do these 4 practice problems yesterday. I'm going to show you the answers and let you check it. Then you can put this paper away. Wake up.
What is 48? Oh, yeah, 48.
We're just in there. You're going to see this.
You're checking your answers on the back, and then once you have it checked, you are putting it away. It is 47, and then I just passed to you 48. All right, 48 is lines of symmetry. This is one of my favorite sheets to do because this is page 28. This is one of my favorite pages to teach because for the most part, what is it?
48.
What did I say?
28.
28.
Thank you. This is 28 plus 20. 48. Yes, you're right. Thank you for catching that. It's different lines of symmetry. Symmetry is where you can fold a shape and it matches. We've talked about this, right? There's an example of each next to it, and then it's a progression. The picture shows you like step 1, step 2, step 3. So there are vertical lines of symmetry where you can just fold it. That's what we call hot dog style. You can just fold it, write it down the middle,
Hamburger.
like this. And then there's horizontal line of symmetry where you can fold it hamburger style, and it matches. Notice the final image. Notice where it's matching right here. Okay? You looking with me? All right. The new parts. Lines of symmetry, a general line of symmetry. That's where you can fold it somewhere besides vertical or horizontal. What if you can fold it diagonally? Okay, so notice we're not on a coordinate plane here. We're just talking about a random shape in front of us. So you wouldn't say like it's across y equals x. Not here because we're just looking at a picture. So you would just draw a line diagonally and say, hey, you can fold it right here. This is called a hexagon. Hexagon has how many sides? Try again. A hexagon has 6. Here's how you remember that. Hexagon is H-E-X, the X in hexagon, and then the X in the number 6 when you spell it. That's how you remember that a hexagon has 6 sides. This is a hexagon. When you first look at it, it might be overwhelming because of all the lines. But the first line drawn is the one right down hot dog style. Then you have a hamburger style line. Then you have additional diagonal lines that can be drawn. You could fold it. When you draw this line, you're saying that I could fold the image across that line and crease the paper on that line, and the image would match, right?
Mm-hmm.
We also have some more here, here, and here. How many lines of symmetry does that shape end up having?
6, 4, 8.
It looks like it's hard to count, but remember, when one line starts up here and comes down here, that's the same line, right? So if you were to count 1, 2, 3, 4, 5, 6.
It does keep.
There are 6 different lines of symmetry. Can you tell me why do you think there are 6 lines of symmetry? There's 6 sides.
Whoa.
There's a pattern to that, a correlation. It does have to be what's called a regular shape, meaning all the sides are equal. But if all the sides are equal, then the number of sides is your shortcut answer to how many lines of symmetry it has. There's another type of symmetry. It's called point symmetry. This is a nice to know. It's just where they are saying, take your pencil or your highlighter. I'm not going to pass highlighters out because of time. But it's where they're saying that if you can rotate a shape 180 degrees and it is symmetrical, then it has point symmetry. That would mean like a rectangle. If I take a rectangle and I rotate it 180 degrees, does it end up landing back in a rectangle, like in the original rectangle? Everybody looking? Go with me? So if I take a rectangle and I turn it 180 degrees, is it still in the same position? And I'm not talking about like, well, now the top is now at the bottom. I'm talking about this is a rectangle that is upright. If I turn it 180, is it still a rectangle that is upright? Yes. So that means it has what's called point symmetry about it, okay? The next type of symmetry is, what if it's not just 180? What if you could rotate it, say, 90? What shape do you think we can rotate 90 that would land back on itself? A square. Imagine a perfect square, right? Okay, if I had a square and I turned it 90 degrees, does it land back on itself? Yes. Could I turn it another 90? Yes. What about another 90? Yes. What you've just done is the concept of what we're doing right here, okay? So let's turn the page. Look right here. Using capital alphabet letters, I want you to answer these questions right here. Capital alphabet letters. Now, I realize some of these, it matters on how you write the letter. Like B, for instance. What's going on? Go good? Okay. Like B, for instance.
Did you see it?
Yeah.
Yeah.
That's crazy.
I did.
That blows my mind.
But I lost West Virginia.
Oh, I have a couple where I picked Maryland.
Oh, okay.
I still have like 3 or 4 countries.
That's what I'm checking right now. Yeah, it's not gonna look.
Oh, I know my alphabet. Hold on.
No, you
I'm writing them because it's easier. LNOP. Q. Woo! Don't write like me.
T.
S. T. U. My arm's falling asleep. V. W. X.
Why?
My arms hurt. Okay. Anyways, please answer these questions right now with using the capital letters of the alphabet. Okay. Answer these questions. Let me say that I realize the letter B and the letter C really depend on how you write them. For instance, if you write a B like this, there's not much symmetry there. And if you write a C like that, there's not much symmetry. I went with the equal B and the one where C looks almost like a half, like a
Semicircle.
Yeah. So I realize that those two are, what's the word? Nitpicky, I guess you could say. They're subjective. It depends on how you write it. But anyways, answer these questions so then we can move on quickly. I don't want this to take a lot of time.
A vertical line. Oh, this is easy. I'll read the question.
Which way is the It's okay. Just think of the horizon is the imaginary line that when you like look out at the beach, that the water meets the earth. That's the horizon, and it runs this way.
Huh?
Well, you can answer however many letters it says. I'm recording. I'm recording. You can answer however many letters it says, or you can put all of them. Okay, Jackson,
Sorry.
please stop. Yay! Everybody should be trying. Okay, thank you for trying this. I really appreciate it. And now let's go over the answers. So provide 2 letters of the alphabet that have a vertical line of symmetry. This would mean you can fold them hot dog style. Start throwing letters out.
T.
T works.
H.
V,
I.
H,
M.
I,
I.
which one did you say?
M.
L.
M is okay.
M.
For Mooney.
What?
M.
L.
M, yeah, he said it.
I.
O T Y A.
You can't fold L.
Oh,
hot dog
X.
style.
X.
Am I here?
K W.
Okay, I got A, H, I, M, O, T, V, W, X, Y. So if you had any of those letters, you
V.
are correct.
Y.
No, babe. Hot dog. Hot dog style. All right. Now I will. 2 letters of the alphabet that you can fold hamburger style.
B.
I said B because of the way that I wrote it.
O.
O.
S.
A. D.
No, S
A.
doesn't
A.
work.
A.
D works.
C.
I said C because of the way that if you write it kind of like an open circle. Yeah, I said C works.
Does E work?
E works.
Does
A work?
No.
No. Can you fold? Okay. And then of course there's K or X. Okay. So tell me 2 letters. You should have come up with 2 letters of the 4 that are in both of those previous lists, and that would be H, I, O, or X.
Where?
We're on number 3. It says provide 2. I said you should have picked 2 letters of the 4 that were in both of those previous lists. So you're right. Yeah. Now, what letter of the alphabet, it says provide a letter, that has point symmetry, but you cannot fold it hot dog style?
N.
N has point symmetry. If I rotate it 180, I will end up with an N, but can I fold it hot dog style?
No.
You might think, yeah, you can because of the lines, but that bar in the middle would be off.
Yeah.
There's one more letter. Did anyone come up with it?
Z. What?
If you turn Z like a certain 90 degrees, you like an N.
C can't.
If you turn
But
the
also
E-
if you do it with an N, it looks like a Z.
Z.
What do you
I don't-
mean by
Z.
The Z. If I turn that upside down, is it still Z?
Yep.
Yeah.
Okay.
I'm good.
Z works. What about this? Does S work?
S works.
S works. All right, come right here.
Literally.
What letter has infinite lines of symmetry?
Oh.
The letter O. Okay, here's the new part. Here's where I really need you to focus, guys. There are 2 questions on your test tomorrow that come from this paper, this discussion, what I'm about to do. So I need you focused and listening, okay? The majority of your test comes from practicing the page 46 and the rotations. I have posted a bunch of IXL links where you could pick the one that you're bad at and practice it on IXL for free. Remember, it only lets you practice up to 10 questions. So if you need to practice, say, 2 types, watch your numbers. But I have posted those, okay, so they are there for you for free to practice rotations. Look at this right here. It says draw all the lines of symmetry. This is like what's on the test tomorrow.
Miss Holcombe,
Yes,
can I please see Luke Shadwick in the counselor's office?
yes, he's on his way.
Thank you.
You're welcome. Look, hang back for like 1 minute, okay? All right, so look right here. This says draw all the lines of symmetry for the following regular shapes. This right here is very important. Regular as opposed to irregular, right? Regular means two things. All sides are congruent and all angles are congruent. Okay? So when you're reading and you see, hey, this is a regular triangle, that's really important. That's telling you that all three sides are equal and all three angles are equal, which opens up the door to a bunch of rotational symmetry options. Okay? Now, look right here. What shape is this? This is a regular quadrilateral, which we call a square. I want you to draw the lines of symmetry on this square. Meaning, draw where you could fold it and it would match on itself. Now, how many lines should you have drawn?
Oh.
4.
The diagonal.
How do I know there's 4 lines of symmetry?
But also sides.
Because this is a square. This is the phrase that you've got to know. This is order n, which means number of lines of symmetry. It has 4. Okay? It has 4 lines of symmetry. That's because it's a square. Right? Alright, where are they? Well, you've got the one right down the middle. You've got the one across the middle. And then you have the 2 diagonal options. Okay? So you have 4 lines of symmetry. Now, here's the new part. What if I said, what's the smallest degree of rotational symmetry? Meaning, what is the smallest number of degrees that I can turn that and it would land back in the position of that square? 90 degrees, right? Now, I'm going to show you the math behind finding that without, what if it's not a square? What if it's a pentagon? You know what I mean? So here's the math behind rotational symmetry. You need to write this down. The math is, answer me this. What is the 1 degree measure that rotates any shape back onto itself? Every time. What's the 1 number of degrees?
360.
Thank you. It's the boring rotation. The one that I said we're not going to do because it works every time, right?
Every time.
So if I take 360 degrees that we know works, and we see we have 4 equal sides, divide it, and there you get your smallest degree of rotational symmetry every time. Now, what if I said, what's the next degree of rotational symmetry after 90? Well, you simply add that number to itself, so it'd be 180. What's the next one? And what's the next one? The 360 is the boring one. It's a checkpoint. If you hit 360, you did this right. If you don't hit 360, you either divided wrong or you had the wrong number of sides. Okay? This is a regular 3-sided polygon. What do we call that? There's another word for it though. It's a specific triangle. This is an equilateral triangle. How many lines of symmetry should it have?
1, 2, 3.
This has order n equal to 3. Now you might be wondering, how in the world? Do you see the one right down the middle?
Yeah, that's what I
Okay, now I want you to take your paper and turn it. Turn your paper. Now, find another line of symmetry.
Down the middle.
You do? Who? Okay, just making sure. You may be back. I don't know why I see it now. But he's back. Turn your paper, and you're going to see another line of symmetry can run right through the next vertex, right?
Oh.
Stay with me, Tori. And then here's another one. All right. Now let's find the rotational symmetry here. Let's find the rotational symmetry. All right. How do you do that?
360 divided by 3.
Yep. So what would it be? What's the smallest degree of rotational symmetry? Wait a minute. Careful. This one's different.
360. Wait.
Someone in second did that.
180, right? Is that it? Or no? We're all wrong.
No, wait.
No, you don't
120.
need. Thank you. You don't need a calculator. Just divide the 3 into the figures. So 120. So you can rotate that 120 degrees and it will land on itself. What would be the next degree of rotation?
240.
And where did you get 240?
Added it.
You just take the 120 and add it to itself.
Yep.
And the next degree?
360.
And that's your checkpoint, right?
Wow, wow.
Now, here's what you need to know for the test. Don't put this up because I'm going to show you one more thing. You need to know what it means by what is the order of this regular polygon. That means how many lines of symmetry can you draw. You also need to know what is the smallest degree of rotational symmetry. Well, that's simply 360 divided by the number of sides, right? Okay, go to the next page. My mom had to get him, and my father-in-law could not get him, and he should be very good because he has baseball tonight. So.
Baseball.
All right, we're gonna hold off on this because this is a nice to know but not a must know, and our test is tomorrow. I want you to come right here to this. All right. So a lot of people say, when am I ever going to use this? I don't understand why math is so important. Math is everywhere, by the way. Tori, stay with me. You love this, especially after your experiment yesterday. This is the word ambiogram. You're going to see where I'm going with this. Hold on. This is the word ambiogram. I say ambiogram, but I think it's actually ambigram. I'll show you one. This is what word? Algebra. This is what word?
Mathematics.
Please take your paper and turn it upside down.
Maths.
Oh my god.
Mathematics. Algebra. And it's just flipped.
Turn it completely upside down,
I
and do
did.
you notice that you can read them the exact same way? It looks like nothing changed, right? Okay. This is called an ambiogram. It's when you take a word and it's an artistic approach. You design it in a certain font or style so that when you turn it upside down, nothing changed. And the reason for that, tattoo artists do this. This is what I was saying. Tattoo artists do this because let's see, if you got mom tattooed on your arm
You look down.
and you look down, it's actually going to say
Wow.
right? And if you had it say mom to you, it would say wow to everyone else. So a tattoo artist would take the word you want on your, say, arm, and they would, well, it's not necessarily a font, that's tattoo artists are like very talented. Their artistic ability is crazy. Look at this. If you look at how they, the R right here is so low because it's fixing to become an L when you flip it upside down. You see that? So that's something neat. I wanted to show you that. Okay. I'm going to throw you one more paper, and I'm going to direct you to something that you need to see. It's okay, y'all. We're going to make it. And then we'll do a very quick basketball check-in. This paper coming to you right...
Oh.
Can you text Luke and say, Miss Holcombe forgot to hand you a paper that you need? If you can stop back by here. Gracie? Quick.